I built this massive video wall using modular tiles that anyone can make at home. After months of 3D modeling, hardware design, and coding, it finally works. You're about to see the entire design process as well as all the mistakes I made along the way. And at the end of the video, I'm even gonna try to game on this thing. So stick around. What's up guys, my name is Chris Parker and I am a professional hardware engineer, but in my free time I love working with microcontrollers and making these YouTube videos to share my projects with you guys. For years I've been using addressable LEDs to build interesting lighting for my apartment, and last year I got the crazy idea to build this massive wall out of them. And now I think it's finally time to take it up a notch and revisit the LED wall project and try to make it even better. You see, earlier this year I found these Neo Matrix tiles on AliExpress that are 16 by 16 pixels for a total of 256 LEDs. And the reason it's so special is because these were on sale for $5 a piece. And on Amazon, these usually go for about $20 a piece. And I have links to both down in the description so you can compare the prices yourself. But when I saw this deal, I got very excited, and I am impulsive just like most makers here on YouTube. So I immediately bought 100 of them. Now, ever since that moment, they have sat in the corner of my office in boxes, completely untouched, and it's been about 6 months. So I think today is finally the day where we are gonna do something with all those tiles. So here's the plan. I modeled an enclosure for the tiles that separates the pixels for better clarity. I'm gonna combine 6 of those tiles to make a 2x3 panel. Then I'll cut a piece of acrylic down to size and sand it to diffuse the light. I want the wall to show dark shades as well, so I'm going to apply a matte black tint to the acrylic, which should help with the final appearance. To drive the LEDs, I could use an off-the-shelf developer kit, but I'm going to use this opportunity to design my own printed circuit board. I want to incorporate 3.5mm headphone jacks that will allow me to easily connect the panels together. The final wall will be 4x4 panels for a total of 96 LED tiles. So yeah, that's the plan. And yeah, I have already started. If you watched my last video, I actually explained the design of these 3D printed tiles, and I actually printed a diffusing layer on the bottom. The problem with that though is that the plastic was absorbing way too much light, meaning that I had to drive the pixels even brighter and use even more electricity, which was getting way too hot. So the other benefit of removing that diffusing layer was that these took way less time and filament to print, meaning that I could print them all myself. My poor printer was working overtime to get all of these parts done. Each part took a little over 4 hours, and I set up a Raspberry Pi running Octoprint so I could just queue the prints and let them go one after another. When one print would get done, the print head would come down and push the part off the build plate and then start on the next part immediately. Now, if I had no downtime and was running a perfectly tight ship, I could have printed all 96 of these tiles in about 16 days. But because I had some downtime when I was doing filament swaps and when I was first setting up Octoprint, I ran into a few issues. It took me some time to dial it in. It really took me about 6 weeks to print all of these parts. The fun part is now I get to trim off this brim that was there to help with bed adhesion and sand the sides down to be as flat as possible. And I only have to do that 95 more times. This is gonna be a common theme in this build. I do something simple and quick, but then I have to do it again and again and again. It really gives me time to think about how pointless this project really is. But even though I could buy a TV for the same price, I get a lot of satisfaction from learning and building new things that push my skills to a new level. So now that the tiles are done printing, I need to take a break from building. So instead, I'm going to be designing the custom printed circuit board, or PCB, for this project. And that is where the video's sponsor, JLC PCB, comes into play. They offer a full suite of services to take you from design to manufacturing, and even offer full assembly at a very affordable price, making the entire process extremely streamlined. Check this out. If you head over to my GitHub page, you'll find the schematic and Gerber files, which you can use to order the fully assembled boards directly from JLC PCB. Simply upload the files, select your quantity, pick the color you want for your boards, and confirm your order. From here, it will ask you to confirm a few things. Just click OK until you get to this awesome 3D view of the board. Even without any coupons, these fully assembled boards come out to less than $10 each, making this the best way to get your hands on high quality development boards. As you can see, I'm using the latest gen ESP32S3 system on a chip, which has a ton of built-in features features like Wi-Fi and Bluetooth. Very cool. If you want to see why this microcontroller is so awesome, be sure to check out my last video. This is a USB-C port for both programming as well as power. This is a boot button to get to the bootloader for programming, and a reset button that does what reset buttons do, obviously. And we have here a 5 volt to 3.3 volt regulator, because the ESP32 takes a 3.3 volt power signal, but the USB port as well as our power supply are both 5 volts. So we need this regulator. Speaking of power supply, we have some pads up here that we can solder our power supply wires to, as well as the data wires for our LEDs. And then we have a switch here that lets us switch between supply power and USB power so that our lines don't get crossed if both the power supply and the USB port are plugged in at the same time. Finally, I have these headphone jacks here for our data in and our data out. These top ones are connected to serial 0 and serial 1, which you can control in code. And these bottom ones don't actually work because I didn't understand how this part worked, so I shorted the signal together. So just pretend those don't exist. And there we have it. Very nice board. I even snuck my logo in there in the bottom corner. I got my fully assembled boards a week after placing my order, and just look at how perfect they came out. You don't have to be a professional hardware engineer to design your own custom circuit boards. Check out JLC PCB and use my link down in the description to get $60 worth of coupons that you can apply towards your order. Now let's continue this build. So this is 1/8 inch acrylic, also known as plexiglass, and I started with 8 massive sheets and cut all of them in half. So now I'm left with 16 of these sheets that will fit 6 of my tiles on them, so I can get 16 individual panels. The next step is going to be to peel off this protective coating and sand it down to get a frosted effect. And that frosted effect is going to diffuse the LED light as effectively as possible. So I guess we're just going to time lapse this, because this is going to take quite some time. I started making projects like this when I was still in college to try and build a portfolio and help me get internships. To my surprise, it actually worked. I managed to get a 6-month internship that eventually turned into a full-time job designing embedded systems. Even though these projects won't accelerate my career like they once did, I want to keep building crazy things so I can share my story and inspire others to do the same. If you're willing to work hard, you can make any dream come true, even if that dream is as silly as building a giant LED wall in your room. So now I finally have all the tiles prepped and all of the acrylic diffused, and I can start to add them together to make the finished product. And spoiler alert, I already did a test run, so you can see exactly what the finished tile is going to look like. Now, I think the colors look so much more vibrant with this design compared to my original wall, and the smaller pixels make the image look so much more crisp. I'm really excited to see how it's going to look with all 16 tiles up on the wall. This first one was definitely a learning experience though, so here's what we need to not do for the rest of them. You can totally see all of the super glue that I used, so I'm going to need to go light on the super glue for the rest so it doesn't shine through. And when I was trimming this acrylic down to size, you can actually see I cracked a big chunk off there, and down here at the bottom I had to glue a chunk back on. Other than that, I think it came out really good considering this was my first attempt. So now I need to not screw up the next 15, and let's see how that goes. Alright, so the first thing I'm going to do here is pick a good starting corner. Ooh. Gotta be careful there. Obviously, I'm not gonna choose this edge where I cut. I'm gonna choose one of the machined edges and pick this corner to start in. And then I'm gonna take all 6 of the tiles I'm gonna use and lay them out in the pattern that I am going to be gluing them down in. Now, one thing to note is that each of these tiles has a notch that is perfectly centered and a notch that is off-centered. And this off-centered notch is where the tiles are gonna sit vertically because they have, well, here, I have an example here. They have these in the back. You can see the power cable runs down the middle, so this notch is going to be a little off center so that it runs in between those. So you want to make sure that those are vertical here. So that's just what I'm doing, laying out all 6 tiles to make sure that the pattern they're in makes sense. And once I'm happy with that, then I can start to glue. All right, everything looks pretty good here. So I'm going to be using this Gorilla Super Glue Gel XL. XL just means it's a bigger bottle. I have 2 bottles because I don't know how much I'm going to use. I used way too much on the example here, so I'm going to be a little bit more lenient with this one, and we'll see how that goes. All right, so I'm going to take my super glue and give it a few dots. 9 dots should be good, and then I'm just going to take it and put it as close to this corner as I can, leaving just a little bit of overlap because I'm going to be sanding everything flush next. So I want just a little bit of overhang. A little bit of overhang is better than having no overhang. I want to get it as square as possible. All right. And I'm just going to hold this in place until it's dry enough at least. And now start with the next piece. All right. This next one I want to square up as close as possible. The first one. It's extremely important that these front edges line up as close as I can get them. That's how I get this seamless look. If you have any gap there, it's going to show on the other side. I think it's time. It's time to bust out the clamps. That is looking great. So here's what I'm going to do now. I'm going to get rid of all this junk holding everything down. All that junk can get out of here. And I'm just going to take the next sheet and set it on top. And that's going to keep everything nice and flat. And we're just gonna stack them up and see how that goes. So, cue the time lapse. While I glue this stuff down, I'm gonna explain how all of this works, starting with the basics. An LED is a special type of diode that emits light when an electric current passes through it. All diodes, including LEDs, only allow current to flow in a single direction. The color of the light is determined by the type of semiconductor material used. Instead of getting hundreds of different colored LEDs, we can make all of the colors we need using a single red, green, and blue LED. To do this, we need some way to vary the brightness of each color. Unlike a light bulb, which can be dimmed by reducing the amount of energy going into it, LEDs are limited to an on or off state. Let's replace the voltage source with an integrated circuit that outputs a square wave with a 50% duty cycle. This essentially causes the LEDs to turn on and off very quickly, but due to the limitations of our eyes, it appears to be half as bright. By varying the duty cycle of the wave of each of the colors, we can get millions of possible color combinations. All right, team, this has had time to dry now, so it's time to cut all of these panels down to their final size. I'm gonna do that with this acrylic cutting knife and maybe a box knife. Got some tools over here. Just running it along here to score, and same thing on this side. And then once the score is deep enough, I should just be able to snap the excess off, and then I'll have a jagged edge that needs to be sanded down. Pretty sure my neighbors hate me because I've been doing so much sanding for this project, but once we're done with this step, we can finally start the electronics. So I'm just gonna power through this as fast as I can. Let's take a closer look at this integrated circuit. It has an input line that accepts 3 bytes of data, one for red, green, and blue, and then outputs each of those values as a square wave. The neat part is that it also has an output where it will send any subsequent data. This means that we can hook a bunch of these up to one another, and now we have an LED strip. If we line a bunch of those strips up side by side, now we have an LED tile. And I'm using 6 of these tiles to make my LED panels. The ESP32 on my dev board works in a very similar way. It gets pixel data from the serial 0 port through the first headphone jack, then sends any extra data out of its serial 1 port through the second headphone jack. Theoretically, I could connect an infinite number of panels together this way, but it will eventually get really slow. So heavy. Why? Oh my god. Okay, so now we just gotta do some more sanding. It is 98 degrees here in Oregon today, and it's not supposed to be this hot ever, but here we are. Okay, so I wanted to get all of the sanding done, but it was taking forever and it was just way too hot outside. It's even hotter today, so I'm just gonna tint the 4 panels that I have ready, and then I'll have to go back to sanding later, but for now I wanna get these wired up and hopefully get something displayed on them today. Applying the tint is really easy. I've got this section that I've trimmed off that's just a little bit bigger than my panel here, and I have this mixture of water with a tiny bit of soap in it. So the first step is to just get this nice and wet. All right, then I'm gonna lay the tint over the top. Just lay this over. That soapy water will keep it slick so it doesn't just stick down immediately. Okay, and then I'm gonna use this squeegee to get all the air bubbles out. And then the last step is to take this little knife and trim off all of the excess. There we have it. Nice matte black panel. All right, it is finally electronics time. My favorite part of the entire project is finally here. So to do this, I've made it pretty straightforward. All I need is my custom circuit board, a power cable, and one of these LED female connectors, easy peasy, and then 6 of these LED tiles. Now these LED tiles are just gonna snap into place just like that, right? Pretty satisfying, if I do say so myself. Now the ones in the middle are actually gonna go upside down, and that is just to make the code happy. We must obey the code. All right, easy peasy, just like that. All right, and once all the tiles are in place, all we have to do is take the previous one and plug it in. All right, and just like that, all of our tiles are connected together, and it's time to solder to our board. All right, this is pretty straightforward. On my little board here, I have supply power up here, minus and plus. Black goes to minus, red goes to plus. Down here, I have the data pin. This pin next to it is the negative terminal for our connector here, which is this white cable. And then the red one is also gonna go to this plus. So let's do that real quick. Alrighty, the moment of truth. I have flashed the demo code onto my microcontroller here. Let's see if it lights up. Let's go! Seeing the finished product like this just makes the whole process so worth it, and I'm so excited to see how this is gonna look with all the tiles plugged in together. Ladies and gentlemen, the first panel of the LED wall has come down. It's right there now, and that's because all 4 of these are wired up and ready to go, but in order to power all of them, I needed to harvest the power supply. Now currently, this LED wall, every single one of these panels has one of these 5-volt 60 amp power supplies. And for this past wall, they were extremely overkill. You could probably power this entire wall with a single 5 amp power supply. I don't know what I was thinking when I went for 240 amps. Insane. But this is gonna be perfect for this new wall with all these extra pixels in it. I'm gonna have one of these for every set of 4, and I'm gonna be wiring up with this 16 gauge black and red wire, and pretty soon we'll be able to see what all 4 of these look like lit up. Pretty exciting. Let's go, insane.
Well, here we are this time. It starts again, but I really don't know why. Hey, misplaced step, a single slip or fall. It's back to 1-1, I've lost it all. If I'm stuck, I'll call you in. Each stage I'll move through. Well, I know it's a little more. Each step alone brings us closer to that old throne.
These are not the same tint. I thought this looked great until I saw them side by side, and now I'm doubting everything.
So now I'll set the pace. With such short time, yeah, I really must make haste. But I don't know what's ahead, or what the ending will bring. I just need to take a minute and then try again to take out the king. If I'm stuck, I'll go.
The other magnet will be glued onto the panel so that when I stick the panel to the wall, the magnet holds it up against the wall, and this ring keeps it from sliding in any direction, and it'll hold it pretty stationary.
That old throne. If I'm stuck, I'll call you in. Each stage I'll move through. Well, I know it's a little more. Each step alone brings us closer to that old throne.
And here it is in all its glory, the world's best DIY LED wall that you can make at home. If you guys are interested in building something like this, seriously give it a shot. I have all the links to everything you need to do this exact design down in the description. And this did take me several weeks to do, but a lot of that was trial and error, trying to figure out the best possible way to do things. And I still don't think that this design, exactly how I made it, is perfect. There are a few things that I wish I could have done differently. For instance, the panels don't line up completely square because of the way that I sanded them. They're not all exactly the same size. That is something that I would like to dial in the future if I were to do this project again. But you know, a lot of things I am really proud of, like the frame rate on this is seriously impressive. It's about 12 frames per second, and a couple videos ago when I made a single panel for this wall, I was explaining how I was only able to get about 3 frames per second, and that was going to get even worse at this scale. So the fact that I'm able to get these kind of speeds, I'm really proud of, especially with just how good the colors look on this. A big factor to that is the car window tint that gets these blacks so crisp. It almost looks like an OLED TV would if the OLED TV had massive centimeter large pixels. But I know what you guys are really waiting for, and that is for me to try and game on this thing. I teased it in the beginning, so get ready. We're gonna try and throw some different levels of games up there, maybe some single player ones to start things off, and then we'll try a few more challenging multiplayer games to see if it's even possible to play on something like this. So let's see how that goes. So here is the gaming setup. In order to prove that this LED wall is game ready, I'm gonna try and get 3 levels worth of games passed, and we're gonna do some challenges just to see if I can even play games on this wall. Starting with the bronze level, which is gonna be surviving a day in PlateUp. That should be pretty easy. I'm pretty good at the game, and if we just do day 1 on an easy level, that should be a breeze. Level 2, the silver medal, is going to be catching a pal in Palworld. I have no idea how that's gonna go. I don't even know what pal I'm gonna try to catch, but I wanna see if it's even possible. And then level 3, the gold medal, is if I can get a kill in Valorant on the wall without looking at my computer screen. I think that that's gonna be nearly impossible because Valorant is just so fast paced. I don't think I'm gonna be able to click on somebody's head before I die. So we'll see how that goes. Let's jump into the first game. I looked it up. The optimal viewing distance for a screen of this resolution is about 18 meters, and I am about maybe 1 meter away right now. We're gonna see how this goes. Frankly, if I squint, I can actually see pretty well. I'm sure it looks pretty good to that camera from here, just the way all that is set up. But okay, anyways, the first game we're gonna be playing is called PlateUp. Basically, my objective is to serve all of the customers in a day. We're gonna be doing fish, and I'm gonna try to cook the fish without serving somebody the wrong dish and without lighting my kitchen on fire. And I have everything basically isolated to just this little area right here. So we'll see what actually happens. I don't know what button to press to start the day, so I have to look at the screen. Off to a good start. Okay, here we go. Oh, the zoom in actually helps so much. Okay, our first customers, it's a table for 2. Am I gonna be able to see what they want? Okay, 1 red and 1 blue. Okay, actually not so bad. Oh, I picked it up. Okay. Okay, the latency is really not that bad. Now I gotta wash these dishes. Is there anyone outside? Yeah, this is actually going pretty well. All right, what do these guys want? 2 reds. Oh, I put it in the sink. Okay. Oh, now there's someone waiting outside. Gotta wash these dishes quick before they get impatient. Oh man. Okay, it's just 1 guy. Easy. What do you want, sir? A blue fish coming right up. And I cannot read what I did at all. Let's see. We got 32 gold for that day. All right, well, PlateUp seems pretty easy. I think it's time to move on to a game that's a little bit more challenging. Okay, here I am in Palworld, and I cannot see much, to be honest. You can see my bird guy here. Let me ride you, buddy. Oh, yes. Okay, I'm on my bird, and we're gonna try and catch somebody. I don't know who yet. I don't even know if I'm going the right way. Oh, God, I see something. It's like 10 pixels. How do I know? If we just shoot it and find out? Did I hurt it? Oh, God, is it shooting at me? Oh, I jumped off the wall, the edge. Okay, where's my bird guy? Dude, is this guy invincible or something? What am I doing? Oh God. Oh, and I'm dead. I'm dead. No, no. This is so bad. Oh God. So Palworld, huge bust, absolutely terrible. I actually think that was probably harder than Valorant. I seriously underestimated my ability to not only see where the pals were going to be, but also just how much health they had, and seriously underestimated how fast that elk guy was gonna move. So I'm just trying to get 1 kill here. Who am I gonna play? Oh man. Oh, I can't even see my mouse. Okay, I have to use the computer screen to pick a character. Oh my God. Oh, I cannot see this screen at all. What? Oh, okay, I see what's happening. If I squint and back up, this is actually pretty doable. Okay. I'm in a pretty good spot. I have spike! I have spike! Oh God. I have to plant. Oh God. No. No. The funny thing is, like on the camera, this doesn't even look that bad, but just when you're so close to it, It's so hard to tell what's on the screen. I see him, no! I gotta get so lucky if I'm gonna get a kill. Damn it. Okay. No, I can't see them. I can't see. Surely all I have to do on defense is buy a shotgun and sit in a corner, and someone will approach me that I can shoot. This is fine. Why are you pushing out? Oh, did I get that? Or is that an assist?
Spike down B.
Did I do any damage there? They're A. I heard footsteps. Oh god! Oh god. Okay.
One enemy remaining. Spike down A. 30 seconds left. Go, go, go.
Oh, I did it! Oh my god! I got a kill! Holy crap, that was amazing! Alright. Subscribe, and I will see you guys in the next one. That was insane.